Hello, it's Keith here, and this is the first in what I'm calling the SuckShoot series of 6809 assembly tutorials. Now, SuckShoot is a little game. It's sort of loosely based on the more advanced Suck Hunt game I made for the Z80 systems. That game was too complex to port in a reasonable amount of time to the 6809 systems, but I thought for a bit of fun we'd make a super simple version which has the same kind of concept but is much more basic and easier to write on a new system. So SuckShoot is a very simple game. If we just get it onto the screen here, basically you have a cursor, you have bats, they get closer to you, and if you shoot the bats fast enough you will get points. Now if you don't shoot the bats fast enough, if we just wait for this bat, if you look at the top corner of the screen up here, this 04, you will see after a while we got hit by the bat, so our lives have gone down to 03. That's our lives there. So it's a simple game. When we get to 0 lives, we'll get a game over message, and if we get a high score, we'll get told we got a high score, and the high score will be recorded. So really it's a very minimal example of what we can make into a game. And as I sort of often say, if you're starting out with programming and you're just writing a little game for fun, then I think this is the kind of thing that you should be aiming for, in the sense that you know, everyone would love to write the next GTA, but you're probably not going to in your spare time on an old system. But I think most people, if they are reasonably committed to it and do the research, could aim for a basic game that's perfectly fun like this. So as I say, I'm offering this up. The source code is available to download from my website, so you can download it, and as I would say, you can take it apart and make a better game out of it, and if you somehow manage to make money off that, you're welcome to do so. So you're free to use it any way you want to. Anyway, we're going to go over the source code today and have a look. So over we go. Let's take a peek. Okay, so here's the code. We're going to be going over the Vectrex code today. Now, some of the code we're going to skip over. That is the random number generation, the binary coded decimal calculations, and also the range checking, which checks for collisions. And the reason is we covered those in the multi-platform series. That series, we covered the code that would work on any 6809 system. Today, we're looking at the stuff that has been written specifically for the Vectrex version, because I'm planning to port this to the Dragon and hopefully the FM7 as well. So this is just the code that has been tweaked and configured for that system. Now, on the Vectrex, we will be running from ROM, and so the code here that you can see, or all of this code here, is running from read-only memory. Now, this comes into play when it comes to showing some of our messages to the screen. For example, we've got the title screen here, we show SuckShoot. Well, that's going to be fine, but we're also showing the high score to the screen, and we've got this text string here, which is the digits we're going to show, but they aren't the final digits. You see, we're going to patch in the score that is the current high score. Now, the problem is that all of this code here is in ROM, so that's read-only memory. It can't change. So what we're going to do is we're going to create a buffer for the text that we're going to show to the screen, and we're going to copy that text and then patch in the current high score. So these are all of our variables for the gameplay in RAM. The sprite of the enemy, we've got 2 sprites for 2 frames of animation. Amazing animation there. The Neo Geo will be jealous of us, I'm sure, he said sarcastically. We've got the scale, the enemy gets bigger, and of course when it gets to the front of the screen we've died. We've got 2 speed variables that control the movement of the bat getting closer to the screen. We've got the position of the enemy, the position of the player, the current high score, 4 bytes, binary coded decimal, 8 digits, the current score, the current lives, which is just 1 binary coded digit, although it only goes up to 4, so it's arguably not binary coded at all. And we've got the RAM, which is the text RAM, and this is used for showing scores. So this is written, updated with the data that we want to show to the screen at various points for the high score and for the main score during the gameplay. So here's the start of our code. We're just setting up our font here, and then we are clearing the current high score to 0. Now, you'll notice at various points we have to set the direct page. We have to set it to D0 for the functions that are going to use the firmware functions that need to use hardware registers. Those are for hardware control. We need to change it to C8, I believe it is, when we want to use RAM. So you'll see that tweak occasionally. This game uses Chibi Sound, which is my ultra simple sound driver, so we're just turning the sound off. What we're doing here is we're transferring that high score data, the string, to our buffer, our text score buffer. We're using the fake LDIR command. LDIR is a Z80 command, but I've created a script to do the equivalent. So we're just copying from high score to high score RAM, and we're copying this length here. That's in U there, the length. So that's what we're doing. And then what we're doing is we're using BCD show, which has been modified. It uses the print char routine, but the print char routine in this case will actually write to the destination U. And so U is the offset in the string that will point to the actual numbers of the score. And so 4 binary coded decimal bytes will be transferred into the string that we're going to show to the screen. And that shows the high score on the title screen. So we're doing that. Okay, so now we're going to show that title screen. Now on the Vectrex we have to draw everything that's visible on the screen every single frame, so we have to repeatedly do that every frame. So the first thing we're doing is effectively waiting for VBlank. That F192 will wait for the start of a frame. We're resetting our pen position, we're setting those hardware registers, and then we're showing the SuckShoot title at the top, and then we're showing the SuckShoot high score at the bottom. So we're running that show string routine twice. The X and Y coordinates are actually in the text string. The SuckShoot1 is continuous, it never changes, but the bottom one is in RAM because it needs to change depending on the high score. We then reset the pen position, set a very huge size, and we draw the bat to the screen. So we're setting the scale to very large, and then we're setting the enemy scale here. We're setting the X and Y position to the center of the screen, and we're showing that enemy sprite to the center of the screen as a very crude title screen. What we need to do next is wait for the player to press fire. So we read in the joystick, check the fire bit, and if the fire bit isn't pressed, we jump back up to the top of the drawing, and we need to keep drawing that title screen until the player decides to play the game. So as I say, we have to redraw every frame, otherwise the Vectrex will immediately go blank, so that's not going to be so good. Here's the start of our game. So we're randomizing the enemy start position. We're then setting up the text score, this time to be the player's score and the player's lives. So we're doing another transfer there of the new string that we want to show. We're setting the lives to 4, so if you want to cheat, you can make that higher. We're setting the default score, which is of course 0, so we're just repeatedly doing that there, storing 2 words, 4 bytes there to the score. We're zeroing the X and Y position here, so that the player starts in the middle of the screen. We're updating the score string, which is going to be what we show to the screen, and we're setting a default bat speed there. And the bat speed will actually get faster the more times we shoot the bat. Okay, so this is our main loop. So this is just going to repeat for the entire gameplay. So first of all, we've got something called sound timeout. Now, chibi sound takes a single byte, which is the sound that we want to make, but we don't want to make that sound forever, but we don't want to make it for a single frame either. So we've got a counter here. When sound timeout reaches 0, we'll silence the sound. So that's just to stop sound. What we're next doing is we're waiting for that start of redraw, the VBlank as I often call it. So we're waiting for the draw to start. Then we are showing our text. That's going to be the score and also the high score. You can just see that very simply up here in that animated GIF there. So that's what we're drawing here. We're then resetting the pen position. We're then showing the enemy sprite at the enemy X and Y position. Resetting the pen position, that resets the cursor because all of these are done as offsets otherwise. And then we're showing the player's target, which is our target that we can shoot that bat with. What we're doing next is we're using read joystick, which is reading in all of the directions and the fires. Now we're going to skip over the next bit fairly quickly because it's based on the simple series where we moved a sprite around. But basically what we're going to do is we're going to test each of the bits. If the bit's not pressed, we're going to skip over the next section, but if the bit is pressed, we're checking the current extremities of the position of the player. So we don't want the player to be able to go off the screen. So if the player is pressed right, we check if they're at the far right, and if they're not, we're going to move to the right. Same for left, same for up, and same for down. Now the only tricky thing is we have 2 possible move speeds. So we're either going to move 2 units or 8 units if the player has fire 2 held down. That's because as the game gets harder, the bats are going to start moving at us more quickly, so we need a way of getting to them more quickly. So we've got that as an option to speed up our movements. So that's how we're dealing with player movement. Then what we're doing is we're checking if the player has pressed fire. If the player's pressed fire, we're going to make a fire sound. We're just passing a byte there to chibi sound to make a bit of a sound, and we're setting a timeout for when that sound is going to end. We're then loading in the direct page with C8, which is our variables, our RAM variables, because we're going to use the range check routine that we wrote in the multi-platform series, and that's going to test if the player has shot the enemy correctly. And if they have, we're going to branch. We're going to continue because the accumulator will be set to 0 if they've missed, and it will be set to 1 if they've hit. So if they've hit, we make a different sound. And then we increase the speed of the enemy, randomize the position of the enemy, and we give the player some score. Now, BCD score add is a binary coded decimal 4 bytes that equate to the value 5. And we're running the add routine to add that to the player's score. And then we update the score string so that when we show that next time, it will have more score. Now, whether the player pressed fire or not, or hit the bat or not, we end up here. We update the new XY position of the player. We're then setting our variables for RAM variables again. We are then we're checking the speed here, and if we need to update the speed, basically we've got 2 bytes, a sort of a low byte, and when that rolls over we update to the high byte. And if the high byte has changed, then what we're doing here is we're going to actually increase the scale of the enemy. We're then going to check if the enemy is what we're defining as the foreground of the screen, in which case the player has been bitten. So we then reposition the enemy. We make a sound for the biting. We set the delay again. We decrease the lives of the player, and if the lives of the player have reached 0, the player has died. Otherwise, we just update the score because the lives are part of the score, and then we continue here and we jump back to the start of our main game loop here. So that's basically the entire gameplay loop there. Very simple. We've just got, show our objects on the screen, test the player's position, move the player, check for the player fire, update the enemy, check if the enemy's hit the player, got to the front of the screen, and we reduce the lives and check if the lives have reached 0. There's no way you can win this game. It just goes on forever. So that's all we've got. Very simple game. Now, the last part of the equation is the game over routines. We use the BCD CP to compare the player's score to the high score, and we've got 2 versions depending on if the player has got a high score or not. If the player has got a high score, we copy the 4 bytes of the player's score to the high score, and we just show a nice game over new high score message. We wait for the player to release the joystick up here, because otherwise they'd probably miss if they keep firing away. We then read the joystick here, wait for them to press fire, and we then show the title once they've pressed fire. The alternative version's almost identical. Of course, we don't update the high score, but we still show text strings to the screen. But instead of showing the nice game over new high score message, we show game over you suck, because the player has not done very well and we want to encourage them to do better next time. Now, that's basically the entire game. You've got some text strings, as I say. These just define the position and the text show. We've got the binary coded decimal add for 5 points there. If you want more or less points for your player hitting the bat, you can change that. We've got some packets. We've got 2 bat packets. There's the first one. There's the second one. That's for the 2 frames of animation for the bat. And we've got the crosshair target. And then we've just got some other functions here, which I'm not going to go into. I think I've covered them all in the simple series in the past. And the random number generation and the range checking we've covered in the multi-platform series. So there we go. That's all we're covering today. Now, as I say, you can go to the website, download the source code, and download the pre-compiled game and have some fun with it, hopefully. Because, as I say, I'm hoping you can take this and maybe make something a bit better out of it, maybe if you've got some more time. The original SuckShoot game was a parody of Operation Wolf, so it had scrolling backgrounds and little objects on the on the background and power-ups that gave you different firing mechanisms and different kinds of bat. So if you wanted, you could extend that and build that into more of a game like that. Anyway, I hope you've enjoyed this today. If you have and you want to support my content, you can always buy my book. It doesn't cover 6809, but it covers Z80, 6502, 68080, 86, and ARM. It's called Learn Multi-Platform Assembly with Chibi Akumas. It's available on Amazon, and I will be writing another book that covers 6809 in the future. You can also back me on Patreon. You can see all of the very kind people who allow me to keep making this content by backing me over there. Anyway, hope you've enjoyed this today. Thanks for watching, and goodbye.